Yeah, it's fine. Right. Hello YouTubers, and welcome to another video of mine with programming for creating a small, simple game setup. At the moment, if you remember last time, we've done collision checks so that we can move our character around and have a few little different events happen when he bumps into things. Today I want to change things up and restructure and build our game to have a better structure going towards the future. To explain it, at the moment in our script file, whenever we add a new item in, let's say we want to add the main square or another square or a grid of squares in, we then have to go into this draw function, our draw square function, and we have to ask for all of these items to be drawn manually. And it's kind of inefficient, and I definitely want to step away from this so that we can scale it more into the future. So what I've done is I've created a new file called script.js. Script.js? No. Display.js. My bad. Here is our file, display.js. It doesn't do anything at the moment, but we're going to start adding to it very quickly. The idea is that it's going to be able to store references of a stage. The stage is going to keep references of all the items on the screen, and it's going to make sure that all the items are drawn without me needing to ask for specific things to be drawn. It's also going to allow me to handle things like the order that things are drawn in, add special effects to them, and add parent and child relationships. So let's say if I want to attach something to another thing, like these two objects are stuck together, if one of them moves around, the other will move around with it. We will have some demonstrations, examples of all of these things by the end of this video. I'm going to move things along a lot faster though, just to start things off. We're going to first copy paste this line and rename it to display.js. That way the display.js file is here. Next up, I'm going to take the rectangle function from over here. I'm going to cut it out and I'm going to paste it into here. There we go. Next up, I'm going to create two new classes, class stage and class DisplayObject. Now I'm going to add a keyword extends onto the stage and rectangle. The stage is going to extend the DisplayObject, and the same thing is going to happen for the rectangle. What this means to the rectangle and the stage is similar to the best way to explain it is to compare a square to a rectangle. Every square is a rectangle, but not every rectangle is a square. Every square is a rectangle, not every rectangle is a square. It's the same thing here. Every rectangle that we make is a display object. Every stage that we make is a display object. Inside the constructor functions, I'm going to call a command called super. What super does is inside the display object we'll have a constructor, and when we call super inside these other items over here, the constructor of display object will be called. I'm going to cut out the half width, half height, center X, center Y from the rectangle, and I'm going to insert that into the display object now. So the rectangle can still have a half width, half height, even though it's written into the display object. That also means that the stage can have a half width, half height, center X, center Y, even because it's written into the display object, and both of these items can do everything a display object can do. I'm going to add in some skeleton functions into skeleton variables into here. So it's going to have an x, a y, a width, a height. These are variables that you're all familiar with already. Now I'm going to add just a few more in that are going to be kind of new to you. This dot parent equals undefined. This dot children equals an array, an empty array, a list of sorts, if you will, like a shopping list, or yeah, like a shopping list. Apples, oranges, pears, etc. And then this dot layer equals 0 by default. We'll get to what layers do in a while. And then this dot blend equals undefined. We'll get to what blending modes do later as well. I'm going to add in some skeleton functions inside here just to start off with. So I want the display object to have a function called addChildren, and it's going to be passed a sprite as an argument. It's going to have a removeChild function with a sprite as an argument. It's going to have a sortChildren, and it's going to have a getLayer, where it just returns this dot layer, a setLayer function. This will slow me down so you can keep up with me a sec. I'll keep that empty for now. And get layer, set layer. That's all I need inside here for this. This is a bit of a skeleton setup that we've got going on here, as you can see. So the display object has its constructor, where it initiates all of these variables to start off with. It has some gets here, addChild, removeChild, sortChildren functions, where it's going to be able to handle all of the sprites that it's been given as children, references and so on. And then it's going to have getLayer, setLayer, fine. Stage, let's start on the stage function. The main thing we want for it is to have a draw function, and the draw function is going to need to be passed a reference to the context. Now in here you're going to recognize a lot of the stuff that we've had before. So we're going to have context.clearrect 0, 0, as in, x position 0, y position 0. Then we need the width of the context, and we need the height of the context. I've got to quickly jump back over to script because this is something I had not written in before. For the resize function, when we set the canvas.width, we're going to add in here context.width as well, and the same thing on the height. So the canvas.width is equal to the context.width, which is equal to game width times scale. Again, that's canvas.height is equal to context.height, which is equal to game height times scale. They're both going to, these two variables are going to both equal the game width times scale. Now over here, when we ask for the context.width, it will know what the width of the screen is. Now we're going to make a little skeleton function here called display, and it's going to have a sprite as an argument. We're going to initiate a sort of loop, if you will, by first calling off for this dot children dot for each, and for each is a array function. We're going to go through a lot of functions related to built-in functions related to arrays. For this one, for each, it's going to basically perform a function for us that applies to everything it finds in the list of its children. So for every object in the children list, it's going to do, we're going to call that object in the list a sprite. So whatever it found here, if it was a carrot or a potato or an onion, it's going to call it a sprite for the sake of this argument here. It's going to then display that sprite. inside the function display, it's going to do the context.save, like you've seen us do before. It's going to do if sprite.draw, if the sprite has a draw function, then sprite.draw sprite. No wait, context. Yeah, pass a reference of the context into it. Then if sprite.children.length is above 0, see by default, if you haven't got any children in it, the length of it would be 0. If you have even one child attached to this sprite, then it would have a length of 1, and so on. So what we're going to do is sprite.children.forEach. So for each child found inside this sprite's list of children, we're going to call up DisplayChild. So all of the children inside every other like sprite, we're going to start with the stage. It's like a pyramid scheme. The stage is at the top. It's going to have references to children attached to it, and some of those children are going to have children of their own, and it's going to be like looking at a family tree, and it trickles down and all the descendants and ancestors, and it's going to draw all of them onto the screen for us. After it's done that, we're going to do context.restore, and that just about finishes off the stage object there. What we want to do next is create some quick functions. Function rectangle, and when we create a rectangle, we want all of it's basically going to have all of these arguments that we have in the class rectangle. So we're going to paste them all here, and then let sprite, we're going to create a little sprite here, is going to equal new rectangle. And inside that, we're going to pass in all those arguments that we just had. Stage.addChild sprite, return this sprite. Now over here, instead of calling off main square equals new rectangle, we're just going to do main square equals rectangle. And that again here, and again here. It will still, and because of the word return, we'll still get this rectangle back. We'll still have a reference to it here, but now we don't have to always create a reference. We could just create, you know, let A equals rectangle, some random numbers, if you let me a sec, purple, and then it's made, it's added to the stage for me. Oh, the stage though, I haven't actually created that yet. Function make stage, let sprite equals new stage, return stage. And then over in this script here, where I created the canvas and context, I'm going to create the stage here. And after I've set the canvas width and height up, I'm going to do stage equals make stage. Because in display we return this sprite, that reference of this sprite, which is a new stage, is passed over to the script to make stage here, which is good. Now, instead of this draw square function, which we call in the update cycle, I'm going to call stage.draw context here instead. So that's where we're going to draw all the items. Now I've made those two functions here. Do I need any other skeleton functions? I don't think so. I think that's all I needed in here. Now I need to start populating the stuff that I want to do with this addChildren, removeChildren, and sortChildren, and setLayer functions. First off, in the addChildren function, we need to first find out if the sprite in question has a parent or not. because a sprite is only allowed to have one parent at any point in time, when we give it a new parent, we need to make sure that the old parent loses the reference to this sprite to one of its children. It no longer needs to look after that child. Another sprite is going to look after that child instead. So what we then need to do is sprite.parent.removeChild sprite. So the old parent is going to forget about this sprite and no longer need it. Meanwhile, the sprite's new parent is going to equal this. So sprite.parent equals this. Now it's got a new parent. And then this .children.push sprite. What push does is it takes your list of items over here, and now it's going to push a new item into the bottom of the list. So we had 3 items before. Oh, we've pushed the 4th item in. We do push again. We've added a 5th item in. Same thing. Now into the removeChild function, where we've got a sprite. If sprite.parent is equal to this. So if the sprite in question, if its parent is this object, this display object that we're telling it, then we need to splice. We need to use another array function, another array built-in function named splice. What splice does is first we give it an index, which is where in this list, which item in this list is this sprite at. Is it the first item, the second item in the list, third item? So that's the index. Next up is how many things do we want to remove, which in this case is going to be 1. We want to remove this one item out from this list. And then the third thing, which is optional by the way, is do we want to add new items in? New item, new sprite, another sprite. We could add all these new items in at this position in the middle here. But for the sake of the removeChild function, we don't want to do that. Now, how do we get the index of the sprite inside the list of children? We want to use another built-in array function called index of. This .children, an array, .index of this of sprite. So it's going to look through this list. Are you Joe? Are you Joe? Are you Joe? Oh, this one's Joe. Then this is at position 0, 1, 2. Position 2. The index of Joe is 2. Now we remove this one from the list, and that is how we do the removeChild function. Now in the sortChildren function, this children and another built-in array function called sort, and it's going to be a function like this. If it's confusing, don't try to figure it out, just copy paste what I'm writing, but basically we pass it an argument which is A and B, which you can imagine would be square A and square B on this screen here, the red one and the purple one. It's going to say, is the layer of square A higher than the layer of square B? And then it's going to sort them accordingly so that we go from the smallest layered number to the highest layered number through the list. Now in the setLayer function, this .layer is going to equal, right, first off in the setLayer function, setLayer, we need to give it a value. We need to pass it a value. So this .layer equals that value. This is not much different from a normal get and set operation until now though. If this .parent, then this .parent .sort children. And what this now basically does is it tells the parent object to sort its list of children out with their layers all into the right order, so that the items that we want to be drawn first will be drawn first, and then the items later on down the line will be drawn later. Now I'm going to save this all. I'm going to have a quick look-see to make sure that this works or not. There will probably be at least one mistake, and I've just spotted one here. When you make the array, this double nested array of new squares, just set that to rectangle instead of new rectangle. That should be fine. Let's see. Oh, I've got it almost just about all right in the first place. Hey, I even made that little new square there over there. Right. That's fine and dandy then. Except for what looks like, you know, our squares are being drawn behind the double nested array that we've got going on here. And there is a quick fix to that. We could just say main square dot layer equals 2. Remember, all of the squares layers at the moment are set to 0. So if we set the square layer to 2, now it is being drawn on top of this grid behind it. But for the purposes of this video, I'm going to show, well, because I added in something called global composite, or blend, I wrote blend, didn't I, into display object, it's got blend undefined. Well, now I'm going to show you why I did that in. Into the Rectangle.draw function, if this.blend, then context.global-composite-operation equals this.blend. Now, back to the script over here. When we created this double nested loop, this double loop of squares, this grid of squares, I'm going to say new square dot blend is going to be equal to, I've got a list here of all the available ones. I think it's destination over that I wanted. Yep, it's destination over I wanted. Now, if you're confused as to what destination over does, I'll try to explain as best as I can. Every frame, we are clearing the screen completely. It is like looking through glass now. It's see-through. As we put sprites onto it, it's like putting stickers onto this piece of glass. When we set the blend mode of the grid of squares to destination over, it makes it that they are pretty much painted behind anything that's already on this glass canvas screen. So they are being, even though they're being painted after the other objects are being painted, they are being painted in such a way that they appear underneath everything. Why would you do this, you might ask? Like paint everything back? It looks like you're painting everything backwards. Normally you'd want to paint the floor tiles on first, then you might want to paint the objects and the player on top, and then the GUI on top of that. I have a bit of a reason why I wanted to do it in this special way. So let's take another square, and we're going to send the blend mode of that to multiply, in quotation marks please. I think at the moment, now we can see this effect going on here. Or we can use overlay. If you're familiar with Photoshop and layer modes and so on, you'll recognise a lot of these and what they do. So we could set to hue, and you can see different effects going on here. See, this player square, the square that we control, is now set to, its hue is being set by the square it's underneath. Again, why would you do this kind of stuff in a game? Let's say then that if you wanted your character to have a moment of swimming, or you wanted your character to be walking underneath trees, you might still want to be able to see your character underneath the trees or under the water. Using these blend modes and drawing items in a particular order can allow you to have these special effects go on. If I was to draw the floor tiles though, if I was to draw the floor tiles in the opposite order, so let's say the layer was set to -1. Now the problem here, if I drew You can still sort of make out the... Maybe if I don't set this to hue a sec, that would be overlay. Let's use overlay as an example. Okay, what would work as an example? Screen. Sort of, you can see it through with screen. If I drew it in this order, to put the floor tiles at the bottom and then drew this partially see-through item on top, the sprites underneath it are showing. That is why I wanted it in this order instead, so that the player is being drawn first, then the items that I want to have special effects on top of the player happen second, and then the floor tiles will be drawn last behind everything else. So these floor tiles will not be affecting anything at all. I'm going to now add one other thing. This little A rectangle that we made here, I'm not going to make it so tall a sec. Let's make it about 25 by 25, and let's make the position 12 by 12. Now, I want to do main square that adds child A to start demonstrating what this whole process was. At the moment, this is going to do nothing because, well, that's a bit of a bummer. But we're going to start fixing that. So into the stage class that we created, into the draw function and display function that we created, we're going to add a context.translate command. Translate is kind of like move this many pixels to the left, move this many pixels down. And for the purposes of this, we're going to pick sprite.centerx, sprite.centerY. So we're going to move to the center position of this square, and then we're going to go through the drawing commands. If it has children, then we're going to do another context.translate minus sprite.halfwidth minus sprite.halfheight. Now, with these two translations here, into the draw command over here, this is going to be equal to minus this dot half width and then minus this dot half height. Instead of this dot x, this dot y, this dot half width, this dot half height. Now, ta-da! When we add a child to a rectangle, as we have done here, the rectangle is now stuck in that position on top of the other square. So let's say I want this to be 0 by 0. And let's make it more like, I don't know, 10 by 10 purple. We've got this lovely little square stuck in the top left corner of this. We can create a little another one. We don't even have to make a reference to either. We can just say main square to add child rectangle, and we can give it an x position of main square dot width minus 15, a y position of 0, width and height of 15, and purple again. And hey, we've got another square attached to it. We don't even have to have the reference, see? So I could just take this let A, I could just cut out that part. So as you can see, I've added lots of rectangles now onto the screen, and I don't have to create references and remember those references for them anymore. I can remove this draw square function entirely, and I don't need it anymore. That cleans up the code on this page just that little bit more, so that the update function is calling the stage.draw function, and then the stage inside here is handling the stage handles all of these drawings for us in a pyramid scheme like fashion. It draws all of the items attached to each other, and we do not have to think very much or very hard about doing all the individual drawing items for ourselves. The display objects can do that for us. Later on, we'll add in maybe some more functions for display objects. We might want to add in animation controls. We might want to add in rotation effects, skewing, stretching effects, maybe. I might not. But this is where this is making quite a good start towards that. I hope you've enjoyed today's video, and I hope to see you again in the future. Peace!